My voice is audible. We'll check my voice is audible.
Yes, sir. Audible, sir.
Thank you so much.
You're welcome, sir.
So already we have discussed the definition of the random variable. Outcome of an experiment. Assign a real number is called random variable. Random variable classified in two different types: discrete random variable and continuous random variable. In a discrete random variable, x is a random variable which can take a finite number or countably infinite number of values is called the discrete random variable. Next, continuous random variable. If x is random variable which can take all values between the interval is called the continuous random variable. Next, expectation of x. Already we have discussed the expectation of x. Expectation of constant is equal to constant. Expectation of x minus expectation of x, that is e of x minus e of x equal to expectation of x plus y is equal to e of x plus e of y. 1 minute, please mute the mute. Okay. Expectation of x plus by equal to e of x plus b of y. Variance of ax equal to a square variance of x. E of x square minus e of x, the whole square is nothing but variance of x. Already we have discussed this morning in the last class. Binomial distributions, we have only two possibilities, that is success and failure is called the binomial distribution. In a Poisson distribution, binomial distribution, mean NP, variance NPQ, standard deviations root of NPQ. In a binomial distributions, the probability mass function P of capital X equal to small x, that is equal to NCX P power x into Q power n minus x varying from 0, 1, 2, 3, 4 to n. Next, in a Poisson distributions, mean variance is equal to lambda. Mean is nothing but n into p, and the standard deviation is nothing but root of lambda, root of variance. Root of variance is called as a standard deviation. Next, the probability mass function of Poisson distributions, P of capital X equal to small x, that is equal to e to the power minus lambda into lambda power x divided by x factorial, x equal to 0, 1, 2, 3, 4 to infinity. Mean is equal to np lambda. Np is nothing but lambda. Uniform f of x equal to 1 by b minus a. Mean of uniform, very simple formula. Mean is equal to a plus b by 2, variance b minus a the whole square by 12, and the standard deviation b minus a divided by root of 12. So mx of t, moment generating function e to the power bt minus e to the power at by t into b minus a. Next, exponential distributions, lambda e to the power minus lambda x, and the normal distributions 1 by sigma root of 2 pi pi e to the power minus 1 by 2 into x minus mu the whole square. Okay. Now on our simple problems for discrete random variable. A random variable capital X has the following probability function: x equal to 0, 1, 2, 3, 4, and p of x equal to k plus 3k, k, 3k, 5k, 7k, 9k. Now, it is the continuous case. Okay, this is a continuous case. Sum of all things should be equal to what? 1. In a discrete case, summation of p of x equal to 1. Sum of all the probability value is equal to 1. In a continuous case, integral over minus 1 to plus 1 f of x dx equal to 1. Here what is given? Discrete cases is given. So sum of all the values are like k plus 3k plus 5k plus 7k plus 9k. So 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25. 25k is equal to 1. Therefore, k is equal to 1 by 25. Next one of the simple problems, the cumulative distribution functions CDF of random variable is given. Capital. What is the relation between CDF and PDF? So small f of x is nothing but d by dx of capital F of x. And then capital F of x. Capital F of x generally is called cumulative distribution function. Capital F of x equal to integral over minus either the lower limit is always common. Default limit minus infinity, upper limit is equal to x, minus infinity to x, f of x dx. Okay, capital F of x. Suppose capital F of x is given, how to find the small f of x probability density function? Okay, what is the small f of x? Small f of x equal to d by dx of capital F of x. Now, how to find what is given? Find the probability density function. Probability density function is nothing but small f of x. Okay, the relation small f of x equal to d by dx of capital F of x. Now, differentiation of 1, 0. Now 1 plus x into e to the power minus x. Take the multiplication 1 into e to the power minus x, e to the power minus x plus x into e to the power minus x, x e to the power minus x. Minus is common only, Now integral of e to the power minus x, e to the power minus x divided by minus x. And then x e to the power minus x, x e to the power minus x. Please once again, please. Okay. So one differentiation of yes, differentiation of 1 equal to constant 0. So differentiation of e to the power minus x minus e to the power minus x. So minus minus plus and then x e to the power minus x. Using UV method, difference x is keep it constant. Differentiation of e to the power minus x equal to minus e to the power minus x. What will be happen? Minus x e to the power minus x. Already minus is given, it becomes plus. Next, e to the power minus x is keep it constant. Differentiation of x equal to 1. So what should be happen? E to the power minus x. Already given e to the power minus x. So minus e to the power minus x cancel. Finally, we get x into e to the power minus x. Okay. Now similarly, we have to try to solve the problem. Now what is binomial distributions? Okay. In a binomial distributions, mean is 5 and variance is 3. Mean 5 and variance 3. What is the mean of the binomial distribution? NP. Okay, NP is equal to 5 is given. Variance. What is the variance? NPQ. NPQ equal to what is given? 3. So now assume that NP is equal to 5 equation 1, NPQ equal to NPQ is equal to 3. This will be equation 2. Equation 2 divided by 1. What will be happen? 3 by 5. NPQ by NP is equal to 3 by 5. NP cancel. So Q equal to 3 by 5. What is the relation between P and Q? P is equal to 1 minus Q. P is equal to 1 minus Q. Either Q equal to 1 minus P. 1 minus 3 by 5 is equal to 2 by 5. So answer is equal to next. Binomial distribution mean 5 and variance 3. Then what is the mode? So mean is equal to 5, variance equal to 3. The mode of x, that is np minus q, that is lies between np minus q, np plus q. The mode is lies between np minus q, np plus q. Np minus q less than or equal to x, less than or equal to np plus p. What is the np mean? Mean what is given? 5. 5 minus 3 by 5. Less than or equal to x, less than or equal to 5 plus 2 by 5. So after simplification, 5 minus 3 by 5, take the LCM. So 5 into 5, 25. 25 minus 3, 22. 22 by 5, less than or equal to x, less than or is equal to 27 by 5. 22 by 5 is nothing but 4.4. 27 by 5 is nothing but 5.4. That is the x, the mode is lies between 4.4 to 5.4. So approximately 5. It is suitable to use binomial distribution only for small value of n. That is, the sample size should be less. The large value of n, the binomial distribution tends to Poisson distributions. Binomial become Poisson when n tends to infinity. In a binomial distributions, P is equal to Q. Then what is the value of P of x? P is equal to Q. What is the binomial distribution? The proper probability mass function NCX, P power x, Q power x. Here P and Q are NCX, P power x into Q power n minus x. Here P and Q are equal. The base is common. X, n minus x, plus x minus x cancel, we get n. So NCX, P power x. Here what is the P value? P and Q is equal, then is equal to 0.5. NCX 0.5 to the power n. Binomial distribution is here. What is a binomial distribution? Binomial distribution is a discrete distributions. Next. Binomial distributions depends on which of the following one: mean and standard deviation, sample size and probability of success, standard deviation and the number of success, mean and the probability. Okay, the binomial distributions depends only on the sample size and the probability of success. Here, P is very closer to 0. Okay, so n is a smaller. Okay, n is a smaller. So sample size and the probability of success. Next, for a Poisson distributions, lambda is equal to 1. What is the P of x equal to 1? So what is the formula? E to the power minus lambda, lambda power x by x factorial, and x equal to 1 and the lambda is equal to 1, e to the power minus 1, 1 power 1 divided by 1 factorial, e to the power minus 1, e to the power minus 1 is nothing but 1 by e. Similarly, lambda is the mean of the Poisson distribution. P of x equal to 0 is given. What is the e to the power Poisson? P of x equal to 0, e to the power minus lambda, lambda power 0 by 0 factorial, anything power 0, 1, 0 factorial 1, e to the power minus lambda. Next one. Poisson distribution is a discrete random variable. Lambda is the mean of the Poisson distributions. What is the variance? Mean and the variance of the Poisson distributions are equal. that is equal to lambda. Now, a random variable is uniformly distributed in the interval 2 to 10. Variance, what's the formula? Variance t minus a the whole square by 12. 10 minus 2. 10 minus 2 equal to 8. 8 square. What's the 8 square? 8 square 64 divided by 12. 64 divided by 12. Simplification, what will be happen? 64 divided by 12. Yes, I think answer 1. 16 by 3. 16 by 3. So the answer is given. Variance 10 minus 2 the whole square by 12. 10 minus 2 8. 8 square 16. 16 by 12. So 32 by 16. 16 by 3. The standard deviation of uniformly distributed random variable between 0 and 1 is, what is the 1 minus 0 the whole square 1 by 12. Variance equal to 1 by 12. What is the standard deviation? Root of variance 1 by root of 12. Okay. Root of 1 by 12. X is uniformly distributed random variable that takes the values between 0 and 1. What is the value of V of x cube? Here, it is a continuous random variable, you know. How to integrate? No, just integral of that is this uniform is a continuous random variable. E of x cube is nothing but integral of x cube into dx. What is the limit? 0 to 1. Integral of 0 to 1 x cube into f of x. F of x equal to what? 1 by upper limit minus lower limit. So 1 by 1 minus 0, 1. So integral of x cube. Integral of x cube is nothing but x to the power 4 by 4. So limit 0, 1. First put in the upper limit 1. 1 by 4 minus 0. Answer equal to 1 by 4. So that is given. Okay, x cube. So integral of x cube is nothing but x to the power 4 by 4. 1 by 4. Next, binomial distributions. Okay, now come to discuss the problems in the probabilities. A fair dice rolled twice. Fair dice is rolled twice. The probability that order number, okay, this is already we have discussed in the last class. Now come to next. This is also completed. Now come to the problem. An examination consisting of two papers, paper 1 and paper 2. Okay, how many given? Two different papers is given. The probability of failing in paper 1 is 0.3 and paper 2 is 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. See, this is what is given, conditional is given. Okay. Now let A assume the events. Let A be the event that failed in paper 1. Failed in paper 1. And let B be the event that failed in paper 2. What is P of A? P of A is failed in paper 1 is given 0.3. What is P of B failed in paper 2? P of B is equal to 0.2. What is given next? Okay. So given that the student has failed in paper 2, already happened. So conditional probability. The probability that failing in paper 1 is P of A given that B. P of A given B is equal to 0.6. P of A. Oh, please run. Okay, please wait. Oh. So given that the student has failed in paper 1, the probability of failing paper 1 is 0.6. This is the conditional probability. So P of B, A given B. Okay. So given student has failed in paper 2, already happened. The probability of failing in paper 1 is 0.6. That is P of A given B is equal to 0.6. Now, what is the formula A given B? P of A given B is equal to P of A intersection B divided by P of B. By taking the cross multiplication, P of A intersection B is equal to P of B into P of A given B. What is the question? Find the probability of students failing both papers. Both the papers with A intersection B. So P of A intersection B is equal to P of A given B into P of B. By using the conditional probability, P of A given B is equal to 0.6, P of B is equal to 0.2, 0.6 into 0.2 is equal to 12, 0.12. Okay, so answer is equal to 0.12. Where is given? Option C is the correct one. Now, this is also already completed in some morning. Next, a fat coin is tossed 10 times. A fat coin is tossed 10 times. What is the probability that only the first two success will hit the head? What is the probability that only two success will hit the head? The option is four different options is given. Now, let A be the event, the first process is head, and let B be the event, the second process is head. So P of A 1 by 2, P of B 1 by 2. First two success, first two head. That is totally how many times? 10 times. 1 by 2, 1 by 2, 1 by 2. Okay, here both are equal probability. Okay, you can use the binomial distributions, either you can use directly. Now, so P head is equal to 1 by 2. So P of probability of head is equal to 1 by 2. Probability of tail is equal to 1 by 2. Now 1 by 2, 1 by 2. First head into the remaining will be what? Tail. So 1 by 2 into 1 by 2. How many times? 8 times. So 1 by 2 to the power 2 head. So the remaining into 1 by 2 to the power 8. So totally 1 by 2 to the power 10. A fat coin is tossed independently 4 times. That is, each coins are independent. Here, you can use the binomial distributions. Either you can use direct mode. You can use any one of the method. A fat coin is tossed independently 4 times. The probability of E1, the number of times head shown up in more than number of times tail. That is number of head is more than the number of times. How many times? Now we have what is the more? More than 3 head and 1 tails, either all are head. So more means greater than 2. Greater than 2 means 2 is not possible. 3 and 4 only. So only P of head, tail. So P of head. Here, how many head is given? 3 head is given. So 4. 4C3 into 1 by 3 to the power 2. 1 by 2 to the power 3 into 1 by 2. Now here, how many head is given? 1. 4 head is given. 4C4 into 1 by 2 to the power 4 into 1 by 2. Here, equally likely even 1 by 2, 1 by 2. Either you can use 4Cn, that is 4Cx into 1 by 2 to the power n. You can use any one of the method, we get the same answer only. So 4C3 is nothing but 4. 4 into 1 by 2 to the power 4 plus 4C4 is nothing but 1. So 1 into 1 by 2 to the power 4. Here 4 times, here 1 times, totally 5 times 1 by 2 to the power 4. 1 by 2 to the power 4 is nothing but 16. 5 by 16. Answer is nothing but 5 by 16. Next. In a manufacturing plant, the probability of making defective bolt is 0.1. The mean and standard deviation of bolt in total of 900 bolts are respectively. Here, success is nothing but defective is called success. So P is equal to 0.1. What is the 0.1? 0.1 is nothing but 1 by 10. Okay, next. Q is equal to, so 1 minus, that is P is equal to 1 minus Q, Q equal to 1 minus Q only. Yeah, P is equal to 0.1, Q equal to 1 minus 0.1. 1 minus 0.1 is nothing but 0.9. So how many numbers? 900. So n is equal to 900. Now mean. Now using the binomial distribution. Here now using the binomial distributions. So mean. What is the mean? NP. N is equal to 900. P is equal to 0.01. N into P. 900 into 0.1 is equal to 90. So mean is equal to 90. Next, variance. What is the form of variance? Root of NPQ. So standard deviation. First find the standard deviation is nothing but root of variance. So N into P, 90, into Q, 0.9. So simplification, we get 81. Root of 81. The standard deviation is nothing but root of 81 is nothing but 9. 81 the whole square. Root of also 9 square. Root of 9 square is nothing but 9. Therefore, the standard deviation is 9. Now this is already completed the last class. This one is also completed. Now come to this one. 13th question. The probability of defective pieces being produced in manufacturing process is 0.01. Here, defective is called the success. So P is equal to 0.01. The probability that after 5 successive pieces, only one is defective. So how many try? N is equal to 5. N is equal to 5. So 5C1 into P power 1 into Q power N minus 1. That's the 5C1 0.01 power 1 into 0.99 power 4. After simplification, we get 5C1. What's a 5C1? 5C1 is nothing but 5. So 5 into 0.99 power 4 into 0.1. That is the answer 5. Answer D is the 1. Next, a box having 5 black balls and 3 red balls. A total of 3 balls are picked from the box, one after another, without replacing them. The probability of getting two black balls and one red balls. First, how many black ball is given? 5. How many red ball is given? 3. Please one second. So 5 black balls. So 5 blacks. Please once again. 5 black ball is given and 3 red ball is given. 3 red ball is given. So totally 8 balls. Getting 2 black balls and 1 red balls. Okay, without replacing. First, uh, uh, five black balls is given. So 5C1 by 8C1 into 5 next. So after taking one, what will be happen? Uh, 5C1 by 8C1 into how many black ball is given remaining 4. So 4C1 by 7C1 into next red ball. So 3C1 by 8, 7, 6C1. So 5 into 4 into 3 divided by 8 into 7 into 6. Now, simplification. 4, 8 cancel 2 times. 3 cancel 1 3s are 2 3s are 6. 5 by 2 into 2 4. 4 into 7 28. So 5 by 28 answer. Okay, sir. And the possible, yeah, the probability of possible combinations: black, black, red, red, black, red, black, 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 red, black. You can use any one of them, but because probability, all are same probabilities. First 5 bar is given, taking only one after 5, 5C1 by 8C1. Next, so 4C1 by 7C1 without replacing. So the total ball is reduced one by one by one. Okay. So 5 by 28. Okay. Now this is one of the combination only. So this is one of the combinations, or otherwise the combination may be varying. First black, black, red, red, black, red, black, either red, black, black. So the three various combinations, either BBR, either BRB, either RBB. So 5 by 28, 5 by 28, 5 by 28, 15 by 28. Next. An unbiased coin is tossed 3 times. Unbiased coin is tossed 3 times. The probability that the head turn up in the exactly 2 cases. Okay. Yeah, unbiased coin is tossed 3 times. N is equal to 3. Head turn up exactly 2 times. So 5C, so 3C2. What is the probability of obtained head? 1 by 2. So probability of obtained tail also 1 by 2. And what is the success here? Unbiased coin is tossed 3 times. Head turn up. So the probability of head is the success. P of head is equal to 1 by 2. So 3C2, 1 by 2 to the power n c x, 3 power x, q power n minus x. Then n equal to 3, x equal to 2. 1 minute, please. Three C2 now. Okay. Next, 2 dice are thrown. What is the probability that the sum of the number on the 2 dice is 8? Okay. Now, 2 dice are thrown. What is the probability that the sum of the number on the 2 dice is 8? First, write the sample space. What are the sample space? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, the first 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, like that. Okay, up to 6, 6. Sum is 8. Sum of the first and second dice is equal to 8. 2 plus 6, 3 plus 5, 4 plus 4, 5 plus 3, 6 plus 2. So 1, 2, 3, 4, 5. Okay, the favorable outcome 5. Okay, so the favorable outcome is 5. What is the answer? 5 by 36. 5 by 36. Option A. Next, a single die is thrown twice. What is the probability that the sum is neither 8 nor 9? So what is meaning? So not a 8, not a 9. So the remaining, okay. Now the sample space total number equal to 6. Now what is the probability of sum is 8? 2, 6, 3, 5, 3, 6, 2, 6, 8, 3, 5, 8, 369 448 449 459 538 549 628 69. Okay, this is the favorable outcome. Either 8 nor 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 by 36. Probability of obtaining sum is 8, either 9 is 9 by 38. 36. 9 by 36. Under simplification 1 by 4. Now what is the question? Neither nor, not getting some 8 or not. So 1 minus 1 by 4. So 3 by 4 answer. Now this is the base theorem. Now we will discuss the next one. Consider two events, E1 and E2. Consider two E1 and E2 such that P of E1 is equal to 1 by 2, P of E2 is equal to 1 by 3, and P of E1 intersection E2 is equal to 1 by 5. Which of the following statement is true? Here, what is the meaning? A and B. A and B is an independent random variable mean P of E1 into P of E2. Now verify the relations. So P of E1, so 2, multiply this 2, 1 by 15. This is not true. E1 and E2 not independent. Yes. E1 and E2 is dependent. Okay. Not independent. Now condition is not satisfied. So it is not an independent one. Now next one. This is the yes 19th one. A box having 5 black ball and 5. Now only discussed. Same concept. 5 black. So the previous one is 5 black, 4 red ball. Here what is given? 5 black ball, 5 red ball is given. Two balls are randomly picked one after another from the box without replacement. What is the probability both red balls? Both are red ball. First, how many red is given? First, 5 black ball, 5 red balls. Totally, we have 10 ball is given. First, we have select 1 balls, 1 red ball, 5C1 by 10C1. And again, a red balls. Already one is taken outside. So, remaining we have only 4, 4 by 9, 4C1 by 9C1. 5C1 5, 10C1 10, 4C1 4, 9C1 9, 5 into 4, 20 by either simplification, 5 two tables, 2 2 sir, 5 2 sir, either 5 by 2 sir, 5 by 10 is nothing but 1 by 2. So 2 and by 4 by 2 is cancelled, we get 2 by 9. Yes. A lot has 10% defective items. So the defective item is here such as, so P is equal to 10%, 10 by 100. 10 items are chosen at a random from this list. That is number of trials 10. The probability that exactly 2 of the chosen items are defective. Exactly 2, that is P of x equal to 2. 10C2 P power 2 into Q power n minus 2. P is nothing but defective. Here P is called the defective because a success. A success is defective. Assume the success is defective. P is equal to 0.1. Q is equal to 1 minus P. So 1 minus 0.1 is equal to 0.9 Q. N is equal to 10. P of x equal to 10. Exactly 2 defective. P of x equal to 2. So 10C2 P power 2 into Q power n minus 2. 10C2 0.1 to the power 2 into 0.9 to the power 8. After simplification, we get 0.1937. Next, a single dice thrown twice. Same problem. The same problem means we have already discussed. Same. What is the meaning? Same sample space. What is given? Same sample space is given. What is the probability that sum is neither 8? Now only we have discussed the problem. Same thing. Okay. A box having 20 defective items and 80 non-defective items. Please note it down. If 2 items are selected at random without replacement, what is the probability that both items are defective? Okay, first, what is the probability of defective? So 20 by, so totally, what is the 20 defective and 8 non-defective? So totally 100 item is given. So probability of defective item 20 by 100, probability of non-defective item 80 by 100. Now, what will be the problem? Both items are defective. First one is selected 20 C1 by 100 C1. Again, the defective item will be selected. Already one item is selected, so the remaining will be 19 C1 by 99 C1. So 20 C1 20, 100 C1 100, 19 C1 19, 99 C1 is nothing but 19. So 20 into 19 divided by 100 into 99. After simplification, we get 19 by 495. 19 by 495. But here 19 is given. The 11 base given. So wrong answer. Next. A coin is tossed 4 times. What is the probability of getting head exactly 3 times? Here, you have used any one of the method. Direct, write the all the sample space and identify, either use the binomial distribution. 4 trial. How many trial? 4 trial. N is equal to 4. The probability of update head is equal to 1 by 2. Probability of update tail is equal to 1 by 2. The probability of getting exactly 3 head, that is P of x equal to 3. 4C3 1 by 2 to the power 3, 1 by 2 to the power x into p power x into q power n minus x, 1 by 2 to the power 3 into 1 by 2 to the power 1, 1 by 2 to the power 4. 4c3 is nothing but 4c1. 4c1 is nothing but 4. 4 into 1 by 2 to the power 4. 1 by 2 to the power 4 is nothing but 16. 4 by 16, 1 by 4. Answer is equal to 1 by 4. Next, 3 coins are tossed simultaneously. The probability of getting at least one head, at least. Okay. Now here, what is at least one head mean? So the minimum one, that is maybe 1, 2, 3, 4, 5, 6, or either 1 minus p of x is at most greater than p of, that is p of x equal to 0. Now the sample space 2 to the power a 3 here, here independent and each probability is equal to 1 by 2, so 2 to the power 3 is equal to 8. Number of ways getting tail is equal to 1. Probability of getting tail is equal to 1 by 8. Okay, now probability of getting at least one head, 1 minus 1 by 8, 7 by 8. No, 20. If 20% managers are, this is what is the problem? Yes. Yes, you can use this is a binomial distribution. Okay. The random committee 5 manager consists of except 2 of them technocrats. What is the here probability of success? Probability of success is equal to 20 by 100. After simplification, 1 by 5. Q is equal to 1 minus 1 by 5, 4 by 5. So number of what is that? Exactly 2. So P of x equal to 2, 5c2, p power 2 into q power n minus 2. This is a combination. Yes. And we will discuss next class. Combinations, integrations. Yes. Next. A box having 10 screws and 3 of which are defective. Out of 10, 3 are defective. 2 screws are drawn at random without replacement. The probability that none of the 2 screws is defective. So the 2 is selected, the 2 is none of them selected. So none of defective screw, total is 7. So defective is equal to 3, none of the defective is equal to 7. 3C0. So we have to selecting only 2. 2 is nothing but none of the defective. So totally 7, none of the defective is given. We have selecting 2 of 7C2 into 3C0. 3 defective is given. So selection, none of the selections, so 0. 7C2 into 3C0 divided by how many is given? 10 to 10 items is given. So 2 items is selected out of 10. So 10C2. 7 by 10. 7C2 into 3C0 divided by 10C2 into percentage. Okay, if all the answer is given to the percentage, you multiply the 100, we get the percentage value. So 47. Like the same questions, there are 25 calculators in a box. 2 of them are defective. Out of 25, 2 will be defective. Suppose 5 calculators are randomly picked from inspection. What is the probability that only one of the defective calculator will be included in the inspection? So 5 is selected, only one is defective and the remaining 4 will be non-defective. So, okay, 25 calculators, two of them are defective. So only one defective item is selected out of two C1. The remaining 23 is a none of the defect, that is good quality is 23C4 divided by, so totally 25 product is given. We have to selecting only 5, so 25C5. So 2C1 into 23C4 divided by 25C5, 1 by 3. After simplification, we get this. So this is already. Next class, we have discussed the problems related to the binomial distributions, normal distributions. Two coins are simultaneously tossed. The probability of two heads is simultaneously appearing is. Two coins are simultaneously tossed. The probability of two heads simultaneously appearing is first 1 by 2, again 1 by 2. So head, the probability of update head is equal to 1 by 2 only. So 1 by 2 into 1 by 2, 1 by 4. Next one. There are two containers with one container 4 red, 3 green ball and other containing blue and 4 green ball. One ball is drawn at random from each. Okay, this is the base here. We will discuss next class. Same thing. Yeah, fair. So look at the problem. This is the by coin problem. This is a compulsory problem. A fair coin is tossed 3 times in successive. The first produced the head, then the probability of getting exactly 2 heads in 3 tosses is equal to 1. After the first head, in the first tosses, the probability of tail in second head. So anyway, 1 by 2 into 1 by 2, because the probability of success and the probability of failure is equal to equal. That is the probability equal to 1 by 2, 1 by 2 into 1 by 2 equal to 1 by 4. So the probability of exactly 2 head is equal to 1 minus 1 by 4 is equal to 3 by 4. Uniformly already we have discussed. This is the uniform distribution. Okay. So this is the most important questions. The probability that there are 53 Sundays in a randomly chosen leap year is what is it? Now in a leap year, how many days given? 365 days is given. So that is 52 complete weeks and 2 days extra. The 2 days extra may be any one of the combination, like this combination is given here. Sunday, Monday, either Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, like Friday, Saturday, Saturday, Sunday. Now, what is the questions? Sunday, 53 Sunday. How many Sundays here given? First Sunday, Monday, next Saturday, Sunday. So 2 possibilities given out of 7. So 2 by 7. There are 2 combinations of Sunday in 1 and 7. So the required probability 2 by 7. Suppose same question is given, what is the probability? The probability that the 53 Sundays in randomly chosen non-leap year. What is the non-leap year? Non-leap year is 360. How many days given? 365 days given. That is 52 complete weeks and 1 day extra. The 1 day extra may be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So how how many Sunday? Only one Sunday is possible, 1/7. So this will be will discuss tomorrow. Next class. Two dice are rolled simultaneously. The probability that the sum of the digits on the top surface of two sides is even. How, sir? Two sides is even. What are the possibilities? Anyone? Two sides is even. Please once again read the question carefully. The probability that sum of digits on the top surface of two dice is even. Sum of the number is even. First 1 plus 1 even, 1 plus 3 even, 1 plus 6 even. Next 2 plus 2, 2 plus 4, 2 plus 8, 3 plus 1, 3 plus 3, 3 plus 5. Next 4 plus 2, 4 plus 4, 5 plus 6. Next 5 plus 1, 5 plus 3, 5 plus 5. 6 plus 2, 6 plus 4, 6 plus 6. Now, total sample space equal to 36. Sum of the top is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Sum of the top is equal to 18. 18 by 36, so 0.5. Next. This is one of the important questions. F of x is equal to 1/5 e to the power minus x by 5. The probability that the conversions will be exceed 5 means exceed 5 means 5 more than 5, 5 to infinity. So 5 to infinity 1/5 e to the power minus x by 5 into dx. In a way, what will be happen? E to the power minus x by 5. Integral of e to the power minus x by 5 is nothing but e to the power minus x by 5 divided by minus 1/5, 1/5, 1/5 cancel, and put in upper limit e to the power minus infinity 0, lower limit is equal to 5 minus, so e to the power minus minus plus e to the power minus 5/5 cancel, e to the power minus 1. What is the e to the power minus 1? 1 by, that is the answer. Okay. This is also very important question, sir. Normal distances, sir. No, we will discuss normal next class. Okay. This is the base theorem. Yes, a flat coin is cast 4 times. What is the 2 head and 2 tiles in the reset? So P probability 1 by 2, 4C2. So 1 by 2. Probability of each equal head. That is 1 by 2, 1 by 2. So 2 times 1, 4C2 to 1 by 2, 2 by 2. Okay, students, today class is over. Please leave the meeting. Thank you, students.